Hello, it's Dr. Mears, and today we're going to be going over your outline document for your Games of Chance project. So first, please do not write answers on this document that I gave you. I did not leave you enough space. Please don't write really small and try to write on this document. I would like you to make a new document. Either you can handwrite it or you can make a Google Doc and then go through and answer all of your questions. But please do not hand me this document with writing on it. I want a clean copy and I want it to be nice and neat. So with that being said, let's go. So first on your outline, you're going to state your group members' names and then you're going to state the rules of your game. So I am going to turn to show you how I set mine up. So I am Dr. Mears, hello, and today is going to be a great day. Here are my rules. I gave my game a name. It's called Roll, Spin, Draw, Win. It's $2 to play, and you can win up to $5. I have 3 rounds, round 1, round 2, and on the next page, round 3. I would like you to have between 2 and 3 rounds. Having only 1 makes it too quick, and having 4 makes it a little bit too long. So think about having between 2 and 3. All right, so round 1, I'm going to roll a 6-sided die. Now, when you state the rules, you have got to tell me, if you use a dice, how many and how many sides, because I have many different dice that you're going to see that you're going to be using. So this one goes up to 30. This is a 30-sided die. This one I think might go up to 20. Yep, this is a 20-sided die. So I'm not going to use those, and I'm only going to use one. I'm going to use one standard 6-sided die. So please let me know how many and how many sides. Okay, so we're going to roll it, and if we roll a 2 or 3, we're going to move to round 2. That means I win to be able to go to the next section. I don't win any money, I just win to be able to go to the next round. And I also found the probabilities here because we're going to need them. So doing your rules with the probability definitely helps. So the probability that I'm going to roll a 2 or a 3 is 2 out of 6 because there's 2 sides. There's a 2, or I can roll a, 3 out of 6 sides in total. So that's 2 out of 6, which is 1/3, which divides out to 0.33. If you roll a 1, 4, 5, or 6, you lose. That's it. You could replay, but you would have to pay me another $2. So the probability of a 1, 4, 5, or 6, there's 4 chances. 1, 2, 3, 4 out of 6, which is 0.67. So if we win and we get to move on to round 2, what's round 2? Round 2 is spinning a wheel. Now, on your phones or any type of electronic devices, you're going to be able to get different wheels. Now, I didn't color, I just wrote names of colors and all of a sudden it came up to this. So there's other spinners that you can use. So if for this game, I just chose that spinner and I labeled my colors. So what the player does is they pick a color, and if the color is spun that they picked, then they get to move to round 3, which means they win round 2. They don't get any money, but they just keep playing. They get to keep playing. Yay. So let's say that I pick blue and I spin. And red came up, so I would lose. If blue came up, I would be able to move on to the next round, but that's what happens. So there's a 1 out of 4 chance that that color is spun, which is 0.25. If the color is not spun, the player loses. So the probability that it's not, the color won't be spun is going to be 3 out of 4, which is 0.75. Okay, so if I win and I get to move on to round 3, round 3, I draw a card from a standard deck of 52 cards. So I am going to have cards. You don't have to use all 52, everybody. So you could use, 4. That's absolutely fine. You don't have to use all 52. I just chose to use all 52. So what the person does for this round is takes the deck. I shuffle it. So I'll shuffle the cards, and then I'll put them in front of the player. And the player will cut the cards, so cutting the cards, they'll take half off, and then they're going to flip one over. It doesn't matter. So cut the cards, put them back, okay, and then I flip one over. If the card is black, then I win $5. So let's see. Yay! So I would win $5. If the card is red, then the player loses. They could replay. Again, it's another $2. So black, 26 cards out of the standard deck of 52 is 0.50, so 50% chance. Loses, 50% chance to lose. Okay, so those are the rules of my game. And I also included the probabilities because it's going to make it easier to do the next part. So what do we have to do next? So I should just make these check boxes. Check, check. Okay. List all the outcomes of your game associated and the associated prize amount for each outcome. This is from the booth's perspective. Use a tree diagram. Okay, what do I mean about this? So first, we are going to definitely need my probabilities, okay? And let me flip this because here's my tree. Okay, so this is from the booth's perspective, and that's what I wrote here. This is a tree diagram. So here's the thing. Here's round one. So round one, the person can either choose a 2 or a 3 to win to go to the next game. That's a 0.33 chance. And that's what I have here for my round one, 0.33. Or they can lose. So they can either win or lose my game. Okay. So if they win, 0.33 probability. If they lose, 0.67. If they lose, I get to keep their $2. It costs $2 to play. So from the booth's perspective, I am now in the positive. I keep their $2. Okay. All right. Let's go on to round two. Round two, here, we have to do the color. If the color is spun, they get to win, they get to move on to round three. If they lose, so they made it here, and then they lose, so they went from this branch, yay, round one I won, to this branch, I lost. That means I get to keep their $2, so I am up $2 here. So I have two chances here. I can be up $2 here or up $2 here. Okay, so if they lose, they walk away. They can start over if they want, it's fine. But if they keep going, they get to go to round three. Round three, they have two things. They could win or they can lose. Now, their probability of winning, 0.50. Their probability of losing, 0.50. So the tree is just based on either you win or you lose. That's it. Keep it simple. Now, if the player loses, yes, I get to keep their $2. So here, I'm up $2. If they win, I'm down $5 because that's how much I have to give them. The booth has to give them $5. So the booth is losing $5. Okay, so here's the paths that can happen. Player can win, yay. Player can win, yay. Player can win. Well, booth lost $5. Player can win, player can win, player can lose. The booth is up $2. Player can win, player could lose. Booth's up $2. Or the player could just lose, booth's up $2. So that's what I mean by doing the prize amounts from the booth's perspective, whether they're going to be giving out money or whether they get to keep the money that's coming in. And that's my tree diagram. If you do have questions, please call me over. I will help you out. All right, what do we have to do next? Check. We have to make a table to represent the following. Each outcome, the probability of each prize amount as a decimal, each win or loss amount, and we have to describe it. All right. We're going to check that off because we're going to be doing it. All right, here's my table. Roll, spin, draw, win. Yay. All right, outcome. So just like what I said on the tree, we can win. For round one, we can win. For round two, we can win. For round three, we can win. So looking back at my tree diagram, I'm taking this path. Round one, we can win. Round two, we can win. Round three, they can win. Okay, and so I'm going to take each one of these probabilities, 0.33, 0.25, 0.50. I'm taking that pathway of those probabilities, and I am going to multiply them. 0.33 times 0.25 times 0.5, and I get 0.04125. That's the probability that they're going to win, and I'm going to have to give them $5. So I'm going to lose $5. So that's about a 4% chance that they're going to win my game. And so I'm going to add that in. 4% chance player will win my game. Okay. All right. So let's see. Now, all the other ways they lose. So this one, round 1 they win, round 2 they win, round 3 they lose. So let's look at that pathway. So round 1 they win, round 2 they win, round 3 they lose. So I'm going to take these 3 probabilities and multiply them together. Okay, 0.33, 0.25, 0.5. So there's my 4% chance, about 4% chance to lose. 4% chance lose. I'm not gonna I'm not going to write it as a sentence because they can lose here too. So when they lose, I get to keep their $2. All right. So another pathway, they can win round 1 and lose round 2. So let's see what that looks like. So they win round 1 and they lose round 2. So I'm going to multiply these 2 probabilities together. 0.33 times 0.75, and I get 0.2475. So they have about a 2.5% chance to lose. And I'm just rounding. That's all I'm doing is I'm just rounding. 25% chance. And all I'm doing to get the percent, to turn it into a percent, I'm just taking 0.04 and multiplying it by 100. That's how I get the percent. Here, I took 0.25, I just rounded that, and I multiplied it by 100, and I got 25. So I'm just rounding, everybody. Okay, and I get to dish out that $2. Okay, another way they can lose is in round 1, where they could just straight out lose, and we can see that that's 0.67, so I don't have to multiply there, so I have 0.67 here, percent chance. So they can lose 3 different ways. And since they can lose 3 different ways, we have to add these together. So taking out my trusty calculator, let's add all of these up. And so we get 4 plus 25 plus 67, and we're going to get 96% chance they're going to lose. Wow, this game's hard, everybody. So these 2 amounts, the lose, if you add up all the ways they can lose, and you add up the way they can win, these 2 should add to 100. Does 4 plus 96 add to 100? Yes. So here they have a 4% chance to win, but they have a 96% chance they will lose. That's sad. And again, I get to keep their $2. So this is pretty good. So now I'm going in, I'm starting to explain what my table is and explain what the percents are. And so this is what I want you to do. I don't just want 2 sentences. When you do explain or describe your table, this is what I want you to, these are the types of sentences that I want. So you could go on to say, the 4% chance that the player will win the game, which means that I have a 4% chance that I'm going to be giving them $5. Or 96% chance they will lose. Sentences like that to describe what's going on in your table. You can also describe by saying, if they win round 1, round 2, and round 3, it's going to be 0.04125 probability of that happening. So sentences like this, that's what I'm looking for when I say describe the table. Okay, let's move on. So I did that. And number 5, use the table to create a bar graph that shows the probability of each outcome. Explain the bar graph. A lot of people forget to do the explain and describe. Please do not. It counts. If you don't explain or describe, you're only doing half of it. So I did not do out a full bar graph, but I did write down the elements that I want. So I want to make sure that you have a title. This is what I'm going to be checking for. You should have labels for your axes. The outcome should be on the bottom. So this bar would be win, win, win for those rounds. Win round 1, win round 2, and win round 3. This is a bar graph. These bars should not touch. These bars should be separate. all of them. So don't, because these are separate outcomes, they're not together, so they should be separate. Probability, you should label, this should be your probability. So you could do either percent chance, or you could do decimals, 0.1, 0.2, 0.3, whichever one that you want. But make sure those numbers are there, and make sure the outcome, and you have your labels. Okay, so I'm gonna let you handle that part of the, that part of the, you can do the bar graph. Okay, so let's see what else they want us to do. That's the bar graph. Calculate and interpret the expected value. The expected value is the average amount of money your booth will win if somebody plays your game many times. Write a complete sentence explaining the expected value in the context of your game. Whoops, I'm sorry, I just totally kicked the table. Okay, so the expected value, you're going to take each probability, multiply it by that prize amount, and add them up. And I'm going to do this with you right now. So here, my expected value down here, I'm going to take each probability, 0.04125, multiply it by its prize amount, -5. Okay? Then I'm going to add that to the next one, 0.04125, multiply it by the prize amount, 2. And I'm going to take the next one, 0.2475, multiply it by its prize amount, 2. And I'm going to add that to the next one, 0.67, multiply it by its prize amount, 2. Then I'm going to label it as EV, expected value. I'm going to take out my calculator, and I'm going to multiply it all out and add it. I actually think I have the expected value. It is 1.71. So $1.71. So if a player plays my game many times, the average amount of money I will make is $1.71. Now, here's the thing. This is positive, so this word is going to be make. So if this is positive, I make money. If this was negative, if your EV is negative, then I lose. I take a loss, okay? Or let's just do lose. I lose money. So just be careful of what your expected value is going to be. If this was 0, it's going to be a fair game. Pretty cool. But we want to make money because we're the booth. We always want to make money being the booth. So if this is negative, you might have to go back and you might have to say, ooh, maybe my game's a little bit too easy because I'm going to be losing all of this money. So just be careful. All right. And the next thing, check. If a person plays your game 50 times, how much money will your booth expect to win? Will your booth lose or make money? So remember, if that EV is negative, they lose. And if your EV is positive, they're going to make. Okay? All right, so 50 times. All right, so my average is 1.71. So what I'm going to do here is move this down. And so all I have to do is I just take my EV, 1.71, I multiply it by 50, and I'm going to get 1.71 times 50, 85.50. So I will make $85.50 if a player plays my game 50 times. That's all. Just take your EV and you multiply it by 50. Well, that's pretty good. I'm wondering if my game is too hard. So the next thing that you're actually going to be moving on to is your simulations and your repetitions. So you're going to actually be playing your game 50 times, and you're going to be seeing if you get close to this amount. And if your game is too hard, you may adjust it. You don't have to adjust this work, but you could just adjust it from your simulations. That's fine because you did the work up front. So you're going to test it out. You're going to test it out, see if it actually works like you think it works, and you can make adjustments. So this has been the outline document for your games of chance. I hope it helped. Ask me questions. Thanks.